Hi everyone, we are still on differential equations. Last time we talked about the classifications of differential equations, and we did mention things like linear differential equation, homogeneous differential equation, or non-homogeneous differential equation. So what that all means, we are coming to look at a problem here, and on that problem we'll be able to identify all these terminologies we have mentioned. We start with linear differential equation. If you have, first thing I would like to mention here is that for this topic, differential equations, for you to be comfortable with this topic, you have to have a pre-knowledge of real analysis. It's another topic in mathematics. Because in real analysis, you got to do about differentiation and integration with other things, but that is what is required for this topic. As well as linear algebra. Why? Because you're going to work with vectors here, differential equations. And those vectors, you should be able to calculate the eigenvectors and eigenvalues. So for that reason, you have to have a pre-knowledge of real analysis and linear algebra for you to be able to understand this topic, differential equations. Having said that, let's look at some linear differential equations. If you have a function like this, y dx equals 2x, for example. You know, here you can do direct integration. This is a linear equation, linear differential equation. You can do direct integration here by just writing it this way: dy equals 2x dx. Then you can integrate dy to x dx, when you will get y is equals x squared plus c, where c is a constant. As we said earlier on, with differential equations, the answer you get is always a function. You are not going to get like numbers, integers, no. You get a function. So this is the answer to this one. This is direct integration method we are using now. Another method, say you are given your function like this: dy dx is equals 2xy. This was 2x, now it's 2xy. This again is a linear, an ordinary linear differential equation. So how do you solve this? Here we solve this one by direct integration. How do you solve this? We solve this one by a method called separation of variables. Separation of variables. So How do this? You have the y here. You want to bring this y next to the y. You have x here. You want to bring this, the x, next to x. So what do? You have the y divided by y. This y now goes down. You have 2x. Why I keep writing x as s? 2x, the x. You have separated the variables. Y alongside the y, x alongside the x. Then how do you solve this? You can now do your integration here. You now have 1 over y dy equals 2x dx. If you integrate this, if you now solve this, you will get the ln. This is the natural logarithm because it's a fraction here. You will get the ln, I will say like this, the absolute value of y, so that this y cannot be negative. Absolute value of y. I could have even indicated it here, where y is positive. Here, y is greater than 0. So this now is equals to, if you integrate this, you will get x squared plus c. You want y. So I now take the exponents on both sides. So this will give me this ln here. If I take another ln, it's going to be y. And here, this is going to be e. I'm just doubling the steps. That's why I said for you to be able to understand this topic, you must have done a lot of integration and differentiation, real analysis, because I'm not going to go into that. We are solving differential equation problems here. Those topics you're supposed to have known. I'm not going to go too deep into them. So this now, when you take the natural logarithm on both sides, this will give you e raised to the x squared. This c will come here. But can now change this to a because you got another constant. So this is your final answer. Separation of variables. You have this. Now, but the most common function you get, as we mentioned earlier on, differential equations is a very important aspect in the field of mathematics, engineering, biology, economics, so on and so forth, because they use these equations to model real world problems. Like when you have the coronavirus, how they try to prevent the COVID from attacking other people, how they will know certain area, how many people are going to be affected, how the hospitals can cope with the patients. All these are being modeled using differential equations. A patient with cancer, how would they know his length of time of survival, or how much is left for him to perish? They look at the rate at which the disease is spreading in the body. They use differential equations to give that estimate. When the doctor say, we'll give you 2 years or 3 years, you will die. It's differential equations they use to do that, to give that estimate. So, these are the sorts of things you will see in linear ordinary differential equations. But in most cases, you will come across a formula when you model a scenario, a real world scenario. You come across something like this: dy dx plus p of x equals q of y. So let me turn it into an equation. If you have the y, the x plus me use plus y equals, this one we still leave it at q of x. It's a function of say h of x. Right? Why? Now let us look at this one here. Let us classify this. This is a linear differential equation. Why it is linear? Because the independent variable y is raised to the power of 1. This is 1. We don't write 1 here. This is raised to the power of 1. And it's a first order. Why it is a first order? Again, the differential parts of this is the y, the x. It is not like the 2y, the x squared. This cannot be linear. This cannot be a first order. This is a second order because it's 2. Because here is 1, here is 1, that makes it a first order. Right? And I've said this is linear. Why? Because the independent variable here, y, is the power of 1. It is not the power of 2 or power of 3. And y can only be here, can only appear here and here. Here, if it appears here, it's going to be a function of y. It can only appear like this. So this is called a first order. First order linear differential equation. When you see it appears like this is a first order linear differential equation. So now, and also I want to extend my classification by saying that if this function here after the equality sign, if this was 0, then this is going to be homogeneous. If this function here is 0, it's going to be homogeneous first order linear differential equation. If this is not 0, you are given something here, then it's unhomogeneous. So we shall concentrate on this first order linear, on this homogeneous first order linear differential equation. We shall be solving problems there. The next video, we shall look at a problem. Thank you for watching. Bye-bye.